Okay, so the next kind of thing to do here is you can do a second free body diagram because this is already fairly cluttered. You need to realize that this object can also rotate. So it can rotate around really any point, right? There could be an infinite number of points of rotation. What you want to do is pick a point of rotation that is you pick possible points of rotation at the points where there are forces that are acting. Okay, so again, if you look up here, we have a force acting over here and we have a force acting over here. Right. So if you look at the way the force is written in this initial statement, it's above ground. So this object can tip and it can rotate around this point. Right? So you make this point, like you can say O, you can make it whatever you want, but you can realize that this can rotate, right? And it's so you have a moment, like you could call it moment 1, right? And what you do is you can put the rotation point at the exact spot where the friction is, right? So that the friction isn't part of the equation, right? And then you can look at, okay, well, what are the other things affecting this rotation? Well, you still have the normal and you still have mg. So you're just going to start putting all of the forces you had in the initial free body diagram in here, where you have force here. And then what you do is you just sum